Good morning, good afternoon, everyone. Warm welcome to today's webinar hosted by AAC Kalkitech. And thank you all for taking time out of your busy schedule to join us. My name is Nirmal Tali. I'm handling business development with AAC and Kalkitech. I hope I'm audible to everyone. This will be a listening only webinar. If you have any questions or any queries that may come up during the session, please feel to put in those questions in the questions pane in the webinar control panel. Uh, if time permits, we will try to address those questions by the end of the session, or else we'll send an email with our detailed response to your registered email ID. So, welcome once again. So today's session is on accelerating DER and load integration through flexible interconnection solutions. So primarily, we'll focus on the PG&E's FlexConnect pilot program and how ASC's Kalkitech approved aggregators and gateway solutions was used in that. Okay. So let's quickly walk through our agenda for today's webinar. Here is what we plan to cover. First, we'll briefly discuss on the grid challenge, particularly focusing on the common interconnection delays that many projects face and why innovative solutions are becoming essential for those. Next, we will introduce PG&E's FlexConnect program, explain what it is, how it offers a pathway for faster grid connection. Then we will spend some time detailing ASC's role as PG&E's approved partner. We'll discuss the importance of standardized architecture, a gateway technology adhering to standards like IEEE 23.5, CSIP, and how a comprehensive aggregator platform facilitates seamless aggregation and control. Following that, we'll dive into how the program works, looking at the operational process of FlexConnect and illustrating the real world benefits through specific case studies. We'll also explore how participating in FlexConnect helps in unlocking value beyond just the initial uh, connection, uh, also enabling opportunities for revenue stacking through other grid services and optimizing the asset performance as well. We'll briefly outline the comprehensive ASC solution package covering our product, support, and maintenance offerings designed to ensure long-term success of the system. And finally, we'll dedicate the time at the end for a Q&A to answer your specific questions, if any. Moving on. So the grid interconnection challenges. This slide sets the stage by illustrating the key challenges and trends impacting the grid today, particularly within PG&E territory. Looking at the top row, we see that three different trends unfolding simultaneously. First, the overall electricity demand is projected to increase steadily over the next couple of decades. A major contributor to this is the exponential growth of electrical vehicles, as shown in this chart, and number of EVs on the road is getting rising dramatically. At the same time, there is a massive increase in the customer-sited resources, distributed energy resources. The main middle chart shows the rapid growth where we are already seen in the distributed generations, primarily solar and behind the meter battery storage, which forecast predicting enormous capacity increase in the coming years. Now, while these trends towards electrification and distributed resources are positive, they create significant pressure on our existing grid infrastructure. Let's look at the challenges highlighted below. So we have this increasing penetration of solar storage and large uh, new loads like EV charging stations or data centers all wanting to connect to the grid. However, the traditional methods for studying these connections, interconnections, are often very slow and costly. and those require physical upgrades to the grid infrastructure uh, are not only expensive but can frequently take many years to plan and build. The direct result of these challenges are substantial. We see significant project delays for customers wanting to connect, which can lead to stranded investments and missed opportunities. From the utility perspective, managing the grid become increasingly complex. PG&E faces growing difficulties in handling local grid constraints like voltage issues or equipment overheating, etc. Especially when unpredictable nature of the renewable generation and the new charging patterns comes in. So taken together, these trends and challenges clearly demonstrate why traditional approaches are becoming insufficient. There's a pressing needs for more innovative, flexible, and faster solutions to manage grid interconnections and capacity, which is precisely where new programs and technologies comes to the play. So we'll look at the what is flexible interconnection. The concept of flexible interconnection is. So let's explore smart grid connection approach like for the flexible interconnection, contrasting it with the traditional way of getting the assets connected to the grid. So traditionally, uh, connections are limited by grid lowest capacity. Here, this is calculated under worst case assumptions. This results in a low fixed ceiling, um, capping the system's output well below its actual potential, which you can see over here, as noted here. So this often forces projects to be downsized severely, delayed as well, and even rejected. Even the project may get rejected while waiting for costly and time-consuming physical grid upgrades. While in the other way, flexible interconnection works dynamically with the grid, like a conversation. Using smart technology such as advanced inverters and controls, the system's output can track the actual real-time available grid capacity much more closely. So this allows systems output can track the actual real-time available grid capacity much more closely. So uh, this allows significantly higher power levels at most of the time, only curtailing output uh, briefly or absolutely necessary to maintain the grid stability, which you can see over here. So how does it work? So the approach enables the customer's system, be it a solar or a PV system or storage or EV chargers, to intelligently adjust its power flow based upon grid conditions by communicating with the utility. Just a second. Got a message. Are you seeing slide number 4? Maybe somebody can put. Okay, let me share the entire screen. Hope you are able to see my screen now. Sorry about that. So we're discussing on how the Plus Connect works. So this approach enables customer systems, be it solar or storage or EV chargers, to intelligently adjust its power flow based upon the grid conditions communicated by the utility, often day ahead or near real time. The critical advantage is that instead of facing multi-year waits for updates, uh, customer can often connect much sooner by agreeing to operate flexibly with dynamic limits. So this involves the system adjusting its import or export based upon operating envelopes set by the utility. So think of this as a personalized time varying permissions from the utility. So defining this safe operating range based upon the current grid capacity rather than a fixed continuous limit. Responsive communication and control technology makes this possible. In essence, flexible interconnection unlocks latent capacity on the existing grid. It enables faster project deployment, supports potentially larger systems, and ultimately accelerates our transition by shifting from rigid constraints to intelligent dynamic grid interactions. On, I'll change my slide. So, PGN, what is PG&E's Plus Connect pilot program? And so, quickly look at what the program is and how the program works and who the program is intended for. So first of all, what is FlexConnect? Essentially, it is pathway for customers who can adjust their uh, power usage to get connected to the grid much faster. Instead of waiting potentially years for grid upgrades, they actively manage their energy use based on what the grid can handle at specific times. This allows them to operate while PG&E completes the needed long-term improvements in the grid. So next, how does this interaction function? PG&E Central Control System or DERM system securely connects and communicates with the customer's on-site energy management systems or on-site assets, be it EV chargers or solar PV. The DERMS calculates and send automated hourly power limits, usually a day-ahead schedule based upon the forecast of the grid conditions and equipment capacity. The customer systems receive this instruction and must ensure that site's power consumption or generation stays within these mandated limits. And next, who is this program initially designed for? The primary focus is on large new electrical loads that are seeking connections in the area where the grid infrastructure is already constrained or nearing its limit. Prime example as highlighted here include the EV charging facilities like a supercharging stations or energy intensive data centers, etc. The program may also apply to large energy storage systems connecting in these capacity limited areas of the grid. So, in essence, FlexConnect is a targeted program enabling key electrification projects to overcome the interconnection delays and move forward faster through smart, flexible participation with the grid. On the next slide, so we'll look at the FlexConnect process and the operations on simple terms. So, uh, so this slide breaks it down into initial enrollment process and the ongoing day-to-day operations. First, looking at the process, it's actually naturally with an application step where customers applies for grid interconnections for the project. Next, the eligibility, like a PG&E assess, utility assess the specific site suitability. They look at the existing grid constraints in the in that location and verify that customers' load is indeed flexible, and controllable as required by the program. Following a positive assessment, uh, you move to the agreement phase where the customer formally agrees to the terms of FlexConnect program, crucially committing to adhere to the dynamic operating limits that PG&E will provide. And the final step is setup process where we'll partner with the technology providers like ASC. Customer implement the necessary on-site controls and install communication gateways and um, aggregators, establish communication with the PG&E through the aggregator. Um, and once the end-to-end testing setup communication is set up, ready, and system moves to the operation stage. On regular basis, on normal operating phase, PG&E control system, that is the DERMS system, forecast an hourly capacity available for the load circuit on a day-ahead basis. So based upon this forecast, it sends out the specific operating limits for each hour, typically 24-hour blocks in advance. So these limits are communicated securely via AC aggregator to the site or to the field through the gateway. So then the customer's energy management system, which is managed via aggregator or a gateway, automatically receives those hourly limits sent by the utility. The system internally adjusts the site load, perhaps by reducing the EV charging rates or managing other energy resources to ensure that site operates within the prescribed limits, maintaining the grid stability. So, as you can see, it's a structured process where leveraging communication and control technology provided by ASC, enabling customers to connect faster. Sorry, by becoming active participants in the grid management. Go to the next slide. So, uh, where to say Kalkitech or ASC is fit into the FlexConnect program. So, at this slide, I will highlight we are the PG&E's approved partner, playing a crucial role in enabling customer participation and ensuring smooth operation within the program. Our role in FlexConnect is essentially twofold. First, we function as a PG&E approved third-party aggregator. Yeah, in this capacity, we manage the vital secure data exchange between site or potentially multiple sites and PG&E's central DEMS platform. We are the trusted intermediary, ensuring reliable communication of operating limits and performance data to the field. Secondly, beyond just aggregation, we are providing essential field gateways and controllers. This involves the specific hardware and software installed right at the facility. Our technology is designed to receive the uh, sorry. So our gateways and controllers designed to receive the operational commands transmitted from PG&E via aggregator pathway, and critically, it ensures that site equipment adjusts its load or generation accurately to comply with those limits. So underpinning both aggregator and the aggregator services and the field hardware capabilities is the comprehensive software platform called Kalki.io. This platform provides an end-to-end solution designed specifically for these applications. It handles the complexities of DR aggregation, often robust data management and analytics, also enables precise control strategies and facilitates seamless integration not only with the PG&E's FlexConnect program, but potentially other utility programs and energy market as well. So we'll look into other possibilities of the integration as we move forward with the webinar. So how the FlexConnect work? So this slide gives a more detailed look under the hood of the technical workflow of FlexConnect, illustrating how the information flows and how control is managed, highlighting ASC's integral role in this process. So let's start at the top, the PG&E system. That's PG&E DERMS on the left here uses sophisticated forecasting mechanisms, taking inputs like a customer data, network information, historical trends of the consumption and the generations, weather forecast, etc. And from this, the uh, DERMS determine the safe operating limits for the grid on hourly basis, generating a day-ahead limits for each participating FlexConnect customer. These limits are then securely communicated from PG&E's central DERMS platform to the ASC aggregator, and the ASC aggregator act as a secure approved intermediary, managing communications for potentially many FlexConnect participation sites. So next, the AC aggregator relays the specific instructions and hourly limits for this particular customer's site, that is to the AC gateway and controller, which is installed on site at the customer facility. So looking at inside the customer site, you can see a AC gateway and controller plays a crucial role. It receives the operating limits from the aggregator and communicates these site limits to customer on system. It could be energy management systems, or it could be directly DER inverters, so, or battery controllers. Importantly, our gateway also handles the telemetry, collecting the real-time data from the site meter and potentially individual assets, and send this operational data back upstream for monitoring and verification by the DEMS. So finally, the customer's EMS or the access uses the limits received via the ASC aggregator or ASC gateway to actively manage the site's energy assets, like throttling back these EV chargers or adjusting other controllable loads, ensuring the facility operates within the specified limits for each hour. So you can see it's a coordinated closed loop system. PG&E sets the limit. ASC provides secure communication on-site intelligence through our aggregator and the gateway. The customer CMS systems or the customer DRSS or the EV chargers executes the control and telemetry and send the telemetry back to the utility for compliance. So AC acts as the essential technological bridge enabling this entire dynamic operation. So next slide, standardized architecture. So that's the key for the scalability. So uh, to successfully manage and scale the growing number of diverse energy resources and load connecting to the grid, a standardized architecture is absolutely essential. As the slide emphasizes, the interoperability isn't just nice to have; it's a non-negotiable deal with especially with PG&E. The fundamental challenge is getting different types of devices from various manufacturers to communicate effectively. Relying on proprietary vendor-specific protocols create silos, and simply it does not scale across entire grid ecosystem. So the solution widely adopts here in this California PG&E territory is the IEEE 2030.5 standard, which incorporates the common smart inverter profile. This standard defines the common language for secure and interoperable communication between the utility DERMS and aggregators like ASCs or Kalkitech and the end devices for or the gateways installed at the customer sites. So crucially, this ensures that equipment from different vendors can work together seamlessly. Aggregator and gateway solutions are built on this standard, handling the complexities of downstream communication while remaining flexible enough to adapt to different customer equipment and site needs. So, embracing standards like IEEE 2030.5 is the key to unlock the scalability and building a truly interoperable, efficient grid of the future. I will look at the few case studies, um, which really illustrates the benefits of using the FlexConnect. First, the challenge here. Uh, We have a scenario which involves a large EV charging stations which is around 3.8 megawatt capacity and needs to connect to the power line that already capacity constrained. The core problem is that the traditional grid upgrades to enable the continuity for 3.8 megawatt needs to support needs major grid upgrades for the permission, and it takes years to complete. So the standard fix for the situation is typically the customer connection would be severely derated. That is cut by around 80 percentage. You can see that is around 770 kilowatt from 3.8 for 6 months from April to October. Uh, uh, to ensure the overall grid reliability. The the heat map shown here visually represent this, showing the significantly reduce the capacity during the 7 or 8 months. So, but interestingly, historical data indicated that actual curtailment was only truly necessary for about 5% of the time, highlighting the inefficiency of this conventional integration or interconnection approval mechanism. So, uh, so now look at the solution using flexible interconnection. PG&E DERMS forecast the actual hourly capacity available and sends precise automated power limits specifically to the EV chargers. The AC aggregator and gateway system receives these hourly limits from PG&E and ensures that charging stations operations are dispatched according to the limits set by the utility. The result is dramatically different, as you can see the bottom heat map here. Um, Instead of widespread lengthy derating, charging station can now support its full requested load approximately 90% of the time on an average. This directly leads to much faster project deployment and significantly more optimal use of the charging assets. So this case study shows that how Flex Connect moves beyond rigid limitation to enable faster interconnection, better asset performance through intelligent and flexible gate participation. So there is a similar case study where this is a smart charging truck charging depot with around 5 megawatt capacity. The challenge remains the same as we discussed earlier slides. So, so significant load will be permitted to connect only during the night time from 10 to 2 p.m. That's only up to 60% of the total capacity of 5 megawatt. So during the daytime, from 3 to 9, the site does not have any permission to connect to the grid. So that's the typical problem here, similar to the earlier case study. So with the FlexConnect approach shown on the bottom heat map, the area clearly still has significant grid constraints uh, referred to the dynamic limits. FlexConnect provides substantially more operating capacity compared to the current status quo. So it avoids those prolonged 0% periods, allowing for more constrained charging opportunities. So you can see that I can charge here up to 81 percentage or to 78 percentage instead of 0% for the day. So depending upon the dynamic conditions, customer can make use of the power from the utility efficiently and effectively without causing any constraints on the grid. Okay, so moving on. So talk a little bit on the DR gateways and controllers, which is getting deployed on the field. So this is the essential hardware component that sits at the customer side. So this is a physical device which has been supplied by AC that act as a crucial link between the customer's energy assets and the utility control system via the aggregator. So on the left, you can see the exterior view of this robust gateway enclosure designed for reliable deployment in various field conditions. SENIMA 4 certified device, so it is can be mounted outdoor. So yeah, the diagram on the right gives you an look inside, showcasing the integrated components that makes it function. You will notice key elements of the communications such as the cellular modem, antenna, and Ethernet ports through a switch. And there is also a processing core which interprets the commands sent from the utility and manages local logic. So logic can run inside the core or the attack device as well. So furthermore, there's a gateway includes necessary power supply components, circuit breakers for protection, secure plans for cable entry and surge protection, etc. All the accessories needed for safe and reliable operations within site electrical environments. So essentially, this gateway receives the operational commands like the hourly limits from FlexConnect sent via the AC aggregator. It then interfaces with the customer's energy management systems or directly with the controllable assets, collects critical performance data from these assets, and ensure the size is responded correctly as per the utility requirement. So this robust integrated hardware is a cornerstone of ASC's offerings, providing the reliable on-site intelligence and communication needed for demanding grid interaction programs. So the gateway has got a programming option. It's a custom control programming which has different libraries depending upon the site type and site templates. I can enable different programs into it. There are different programming options. You have a 61131 based programming option, which is more industrial standard option. Um well, this is well suited for implementing real-time cyclic operating conditions and flexible load control functions directly within the gateway using familiar workbench. Alternatively, we have a versatile scripting engines which is based upon Lua language, Lua scripting. This allows for more customized logic, supporting event triggered or cyclic or scheduled executions. Is advantages includes enabling complex edge orchestration and even integrating AI or ML engine models directly into our control strategies via scripting. So when you need a standard real-time control, advanced custom logic with AML or solution, our platform provides programming options to meet those requirements, either through the scripting engine, integrating the AI engine, or standard industrial standard 6131 programming logic engine as well. We'll go ahead and see the integration architecture in more detail. So there are different integration architectures. So this is a standard way, or one of the standard way which integration is done with a local DER like energy storage systems or EV charging stations or charging station controller. Uh, you have we have local controllers managing these assets like a SE controller, the supercharger controller, or a mega pack controller here which manages the battery. Gateway provides the gateway and controller. This is the combined package which sits in the AC solution which sits in the field. This provides a secure communication link, often using a 4G LTE connection back to the AC aggregator platform, and from there data flows to utility or utility backend system, DERM systems, typically using IEEE 30.5 protocol. So this configuration is well suited for general monitoring, control, and participation in FlexConnect programs that primarily require communication through aggregator and the gateway. So this is a standard architecture. So another option is that some of the sites may require participation into the FlexConnect program, as well as it needs to participate into the energy market as well. Like for example, if it's a battery storage systems. So there are different architectures for those kind of systems or sites. Uh, this is one of them. So So the sites perhaps has a battery storage system, so it wants to participate directly in the wholesale energy market in addition to the plus connect. Here what we are making use of is the gateway and controller. Mm, it receives the control day ahead schedule commands from the utility on 2030.5, and the day ahead schedules will be sent to the local site controller, and from the controller will dispatch the signal to the battery energy storage. So controller will also have the signals coming from the energy market, and it can determine the controller can determine the dispatch value which needs to be sent to the battery energy storage. So in this case, it can be third-party controller. All the schedules received from the utility, their schedules for 24-hour blocks, schedules received from the utility on 30.5 can be sent to the controller as a standard Modbus registers, or as per IEEE 1815.2. That's the NP3 extension for the DER schedule transfer. So either to Modbus or DNP3, the schedules can be sent to the local site controller, and site controller can decide and dispatch the assets accordingly. So that's one option, and another option is more advanced scenario where site is a maximizing its value by participating in multiple programs simultaneously. For example, this particular site is participating in PG&E's FlexConnect program, and PG&E has also a program called DIDF, that is a distribution infrastructure deferral framework, and they also will be participating in the market for day ahead market as well as the frequency and ancillary market. So there are multiple value stacking done on this particular kind of a deployment, where the FlexConnect day-ahead schedules will be sent from the utility directly to the aggregator, and aggregator will be integrated with the energy market through a market optimizer, and all the day-ahead schedule will be sent to the market optimizer, and the market optimizer will take the PG&E schedules or the utility schedule, as well as it also uh, uh, bid these assets in the market according to the aligning to the utilities control signal. And once the bid is approved, those control signals will be sent to the back to the site to the aggregator and gateway. And gateway and controller will dispatch those assets uh, uh, to the gate. So in addition to that, the data and the real-time market will come through the aggregator and gateway. This assets, as I mentioned, is also participating in the frequency ancillary market, where it requires a RIG, that is a remote intelligent gateway, uh, which will be having a direct connection from the site to the case market, in this case CAISO, uh, through DNP3. So KESA will also dispatch the signals on the NP3, and those dispatching us will also comes under the controller, where AC supplies. And here we do the stacking of the control signals from the KISO and utility, and determine which control has to pass, and what should be the limit has to which the asset has to be dispatched. So all the logic will be built in the gateway and controller using the logic engine which you see in the previous slide, that is 61131 engine and the script engine. Uh, the controls will be stacked, and then that will be sent directly to the assets. So this is a kind of uh, an advanced architecture where assets or the sites can be can participate in multiple utility programs and the market. Moving on. So we'll look at the deployment process or the configuration and engineering steps. Coming slides. So to ensure our customers having everything they need for successful participation in the commercial or C&I aggregation programs like FlexConnect, we offer a solution as a package with the products, support, and maintenance. So this package simplifies deployment and ongoing operations by building essential components across these three pillars. That's product support and maintenance. First, look at the core product. This includes a versatile gateway, which can be configured with or without an integrated controller, all housed within a NEMA 4 enclosure, suitable for field installation. So this package comes ready with the universal power supply and integrated cellular modem, and also pre-packaged with the AT&T or Verizon SIM card with the fixed IP for reliable connectivity with the utility to the aggregator. So importantly, it also pre-installed with the PKI certificate, which has been approved from by Sunspec, um, and all security certificates for seamless and secure 23.5 communication, as well as for the device management, is pre-installed and pre-loaded before the shipment to the site. On the support side, our commitment extends beyond the hardware. Like we provide ongoing security updates covering protocols, firmware updates, and OS patches to protect against vulnerabilities of these devices. We also offer configuration assistance, engineering expertise, and site support when needed, and convenient online training materials as well. So for long term, we offer flexible maintenance subscription plans covering typical project life cycles for 5 years or 10 years or 20 years. This subscription includes access to our management portal. So there's a device management portal we as well we provide, which is used for managing these gateways and the access remotely through web portal, through cloud. For that's for easy device upgrades and maintenance tasks for troubleshooting, configuration updates, etc. And covers the necessary cellular plans for continuous communication as well. So, in summary, the ASC provides a comprehensive, pre-packaged, pre-engineered solution designed to streamline the entire process from initial setup through the years of reliable, secure operations in demanding grid services programs. Now let's look at the typical timeline or how the uh, deployment happens. So once we have the order from the customer, so we also receive the site data like SLD of the site and the data list or device list, and we pre-engineer, pre-configure the gateways based upon the SLDs and the inputs which we received from the site, and those pre-engineered configuration will be loaded into the gateway and it will be shipped to the customer. And once the customer receives the unit, customer just needs to install those, mount that device and power up that device. So since the device comes with a pre-integrated, pre-installed SIM card, it automatically connects to the network, to the internet, and establish connection with our cloud device management service, where we can directly access these devices and do the fine-tuning configuration updates or configuration any configuration changes as required for the site. And our support team also helps in with customers to do the pre-testing, initial pre-testing with the customer, as well as once the pre-testing is done, we also help customers to do the utility verification testing as well, like SCADA testing or DERMS integration testing, and help you customers to get the PTO and commissioning approval. And once the approval is done, it will go to the maintenance mode where these devices will be continuously monitored by cloud device management portal, and daily basis. We have a report showing which all devices are up, and if there's any issue which has been noticed in the devices, that will be immediately be notified to customer if to rectify the issue if required. So this is a typical process where site installation commissioning is done for the FlexConnect program. So how ASU Kalkitech simplifies customer journey is what we have explained here. So successfully participating in advanced grid programs like FlexConnect can seem complex, involving technology, compliance, communications, and ongoing operations. So here, the Kalkitech is primarily focus on the simplifying the entire customer journey. I can see the uh, um, we simplify the initial deployment and onboarding by providing our pre-approved integrated solution package, including the necessary hardware and software with a pre-engineered solution. So our team also offers expert configuration and engineering support to tailor the setup uh, s- uh, to your specific site requirements. And Kalkia platform serves as a central hub for data management and simplifies operational control and automatically handle dynamic limits and responses required by the program. This also aids in meeting compliances and reporting needs for the sites. So throughout the journey, we act as your technical partner, providing support, ongoing support, and clear communication whenever you need an assistance. So by building the technology, and the approved aggregation services, the data platform, uh, comprehensive support into one package, AC manages many of the technical complexities associated with the utility integration, secure data exchange, operational adherence. So this allows uh, consumers like you to participate effectively and unlock benefits of programs like FlexConnect with greater ease, letting you focus on your primary business objectives. So ultimately, our aim is to make uh, customers' path to successful grid participation as straightforward and manageable as possible. So we'll look at the few value propositions before we close the session. Um, So value proposition, significant value these participants gain by leveraging FlexConnect program pro, is through direct utility participation in the programs like FlexConnect. So this value comes in two forms. So immediate benefits are related to getting your project online and long-term benefits from unlocking the future opportunities. So first look at the immediate benefits. Um, the primary advantage is drastically reduced project timeline and cost, which we discussed earlier. Participations can potentially connect years sooner compared to watch for traditional grid upgrades, avoiding significant capital expenditure and delays. This directly translates to faster time to revenue for commercial operations like EV charging stations or data centers. Alongside the faster connections, you typical access more energy and most of the time. So grid constraints as often only presents during a relatively small number of peak hours per year. FlexConnect allows you to operate at your full requested capacity during all other unconstrained times, rather than facing severe year-round power restrictions, as we see it in a few of the case studies we discussed earlier. So beyond just getting connected, the infrastructure you implement for FlexConnect serves as a crucial foundation for future values as well. This requires communication and control capabilities facilitated by a system like ASC, aggregator, and gateway, which is a prerequisite for participating in a growing number of grid service programs. So this system opens door to unlock new revenue streams and optimize your assets. Uh, you gain the technical ability to enroll in demand response programs and get paid for reduced load when the grid needs it. You can also join virtual power plant programs, aggregating resources like batteries to provide grid services to the utilities. You can also implement optimized operations such as scheduled EV charging to align with the low energy prices or periods when high renewable generation is there. So critically, the AC Kalkitech platform provides an integrated environment to manage participation across these diverse opportunities, helping you effectively stack these different value streams and maximize the return on your energy assets. So, in short, ASC Kalkitech solution is not just an interconnection solution, but as a strategic enabler, positioning your assets for deeper participation in modern, flexible grid energy grid and the capturing additional value well beyond the initial connection. So with this, I'll conclude the webinar session. If you have any questions, maybe we can discuss that. Check if there's any questions. So one question is, what are the supported connection modes? 2G, 3G, 4G, 5G. So right now, our pre-integrated package supports 4G LTE. It can be upgraded to 5G as well. So depending upon the network, so we do have a partnership with AT&T and Verizon. So depending upon the location and the network requirement, I can use 4G or uh, where the location 5G is there, we can switch to 5G as well. So what is the role of site meter? So site meter role is primarily to read the total consumption or generation from the site, primarily to ensure that to read the telemetry data from the site to send back to the terms to ensure the assets are performing as per the limit set by the terms. How's integration with AI for demand forecasting and real-time control, and also not sure if your PG&E case studies has covered the analysis of DR locations. So integration with AI is primarily through the our script engine. So we have a engine which is pre-built and integrated with the um, package. We have a few partners like Bone Logic, which is a pre-integrated AI engine, which is being part of the gateway software. I'm not sure if you're no, we not cover the PGI's case studies of identifying optimal location. So that is beyond our limit. So that's primarily during the site approval testing or in site initial process of enrolling into the program. Okay, so do we need to use a specific hardware or software from ASC, or can we use our own systems to connect to the FlexConnect? So, uh, yeah, PG&E requires participation to use approved communication pathways and technologies that meet specific standards like 2030.5. for secure and reliable communication. So ASC provides a PG&E approved and pre-integrated solution, including the gateway, hardware, and aggregator. Our system is designed for interoperability and can integrate with most of the existing site controllers or EMS using the multiple protocols supported by the gateways and certified end-to-end solution. So significantly, the solution simplifies the technical qualification process, ensures compliance with the utility and the regulation, and accelerates the participation into the program much easily. So yeah, so there's nothing blocking you to connect with the utility directly, but the utility have recommend to get the aggregator pre-approved and pre-tested before getting connected with the dubs. So covered participation in other programs like demand response and BBP. Does the FlexConnect setup automatically enable that, and can AC help manage participation in multiple programs? So the simple answer is yes. This that's a major advantage. So the communication and control infrastructure installed for FlexConnect, that is our gateway or the aggregator, is foundational for many other grid services as well. So while program enrollment is separate, there will be different enrollment process for different programs. Our system in places makes it much easier to participate in other utility programs and also implement economic dispatch strategies like directly integrating with the market as well. So Kalkitech platform is primarily designed to manage participation across multiple programs, helping you to optimize and stack value streams effectively. So there is nothing blocking you to change or participate in any other additional programs as required. Like, we can enable it if you are interested in any additional programs provided by the utility or directly to the market. How is the communication between our site AC and PG&E secure? So security is a top priority for and integral to our system design. So we adhere to strict to utilities cybersecurity requirements and industrial best practices. The communication leverages uh, secure protocols, often based on 2030.5 standard, which mandates the use of PKI certificates for authentication and encryption. So we also have additional certificate for device management. So there's a certificate issued by the device management cloud, which uses it for creating a TLS 1.3 tunnel from the device to with our cloud, and through that connection, we can do the remote access of the devices and do the configuration updates or firmware updates or any patch updates if required. And also the hardware which is deployed in the field is also having multiple layers of security, like it is compliant to TPM 2.0, as well as it has got secure Linux built in, and all the softwares are running on secure Linux, and only signed software will be running on the uh, uh, on that particular hardware. So you cannot load any third-party hardware, third-party software into it unless that software is certified and signed by ASC or Kalkitech. Okay, I think that's it. So we'll share the meeting recordings, and who has shown interest in getting the slides, we will send those slides to your registered email IDs as well. So with this, I'd like to conclude this session on this. So we sincerely thank you for joining us today and for your engagement. We hope this session provides a valuable insights into how FlexConnect program works, and how it provides a faster path for you to connect your projects, and ASC approved aggregator services help you to enroll into the utility programs easily. So we encourage you to reach out to us with any further questions or discuss your specific projects if required. Please Also visit our website and contact our team directly or email or phone. We can help you as soon as we receive your information. Thank you once again for your time and attention. Thanks.